All right, this is lesson 2, multiplying powers of 10. We're going to be exploring patterns with exponents when we multiply powers of 10 together. And the criteria to be successful for this lesson is to be able to explain and use a rule for multiplying powers of 10. So you should be able to develop that rule by the end of this lesson. So we start with this warm-up where we're going to look at some different examples of what different people see. So you have Claire, Tyler, and May, and they all see something different in the picture. Take a moment to pause the screen and reflect on who do you agree with and have a reason for why you agree with them. Okay, after pausing, let's kind of go through who we agree with. You can actually have picked any of the individuals to agree with for many different reasons. So Claire says she sees 100, and that's because she sees 100 small squares, where Tyler only sees 1, and that's because he sees the whole big square as a whole. And then May says she sees a fraction, 1 over 100, and she's seeing each individual tiny square as a part of the whole thing that Tyler sees. So you could have really picked anybody for those reasons. Going into the second part, picture a power of 10. We're going to really get some visualization here as to understanding how these powers of 10 work. So you're going to start off by working on questions 1 to 4 on your own first. This is going to be a moment where you're going to pause in a minute, but just kind of to break apart the diagram, the medium rectangle is made up of 10 small squares. So you start with that small square to the right. Your medium rectangle has 10 of those, and then the large square is made up of 10 medium rectangles. So at that point, let's go ahead and pause the video and try all of these questions on your own first before moving on. Okay, so if you are back from giving this a try, we're going to go through each of these questions and break this down. So how could you represent the large square as a power of 10? So let's just think about some of the things we know already. We know we have this small square, the rectangle is made up of 10 of those, and we essentially know that there's 100 small squares in that big square. So we could think about this as 10 squared, and that's coming from, we know it's a 10 by 10. It's 10 of them from the rectangle, and then 10 of those. So, that's all I have on that slide. Okay, so let's keep going because it'll all start to kind of piece together. So let's pretend that each small square represents 10 squares. So you kind of have to separate this idea of each one being an individual single square, because now they're going to each represent something different. So we have the one that's circled red, that represents 10 squared. So let's take this to the medium rectangle. So we see one of those at the bottom. Those are equal. Each of those circled represents 10 squared, but there's actually 10 of those in that rectangle. So we would say that 10 squared times 10 of them in the rectangle would mean that the medium rectangle would represent 10 to the power of 3. So then we take it even further and we're looking at the big square. Okay, so now still it's going to turn blue now. So now my small square represents 10 squared. So now we have to get to what would this look like as a power of 10 in terms of the large square. Okay, so again, there's 10 of those in the medium rectangle, which is 10 squared, but then there's 10 medium rectangles in the large square. So you're almost like progressing your way up. So we could look at this as 10 squared times 10 squared. So again, small square is 10 squared, 10 of those in the rectangle, right? So that's that times 10 from our first one, times another 10, because there's 10 rectangles in the entire big square. So we would look at this as 10 to the 4th for the large one. Okay, so moving on, we're going to assign a different value now to the medium rectangle. So we're going to suppose the medium rectangle represents 10 to the power of 5. That's what the whole thing represents. So let's go to the large square first. So here you see this entire medium rectangle that is circled represents 10 to the 5th. There's 10 of those in the big square. So that means I'm going to write this as 10 to the 5th times 10, which is essentially 10 to the 6th. Now, if we go backwards from the medium rectangle, we're dividing by 10 because we're breaking it into 10 small squares. And we know the big medium rectangle is 10 to the 5th. So we divide it into 10 parts. And so this time we're actually representing the small square as 10 to the 4th. In this last one, the large square represents 10 to the 100th power. So what does that mean for the medium and the small square? So we're taking something large and we're breaking it into smaller parts. So we know the whole entire thing represents 10 to the 100th power. We have 10 medium rectangles within that big square. So we have to divide it into 10 parts to get to the medium rectangle. That means it's going to be represented as 10 to the 99th power. So now again, starting at the big square and going to the small square, we're going to divide it by 10 to get to the medium, and then we have to divide it again by 10 to get to the small. So that means we're dividing it by 10 twice, 10 squared. So we would represent the small square as 10 to the 98th power. So here's some key takeaways here. When we're increasing the exponent of a power of 10 by 1, it corresponds to multiplying by 10. If we're decreasing the exponent by 1, corresponds to dividing by 10. Let's put this into perspective here with this digital app. Give it a second to load. Okay, so if you notice at the bottom here, you see the size of the dog in comparison to the size of the bird. Now, we have not worked with negative exponents yet. It's okay, but we're just putting this into perspective. So let's say I zoom out and I want to see more. Well, I'm going to essentially see a bigger animal than the dog, which is an elephant. Now, notice I went from negative exponents to exponents of 0. If I zoom out again, I now see a whale, which is larger, right? I'm increasing the size. Now my exponent is positive. So my exponents have all increased. So if we go back to the dog, let's zoom in now because we're essentially zooming in to see smaller animals. By those key takeaways, we're decreasing the size, which means we're dividing by 10. We're getting smaller. So our exponents, you can see, are also getting smaller here because we're dividing. So let's go back here. And again, our success criteria is to be able to explain and use a rule for multiplying powers of 10. So we're slowly making our way there to develop that rule. So in this last activity, multiplying powers of 10, we have a table and you see it's showing an expression column, an expanded column, and then a single power of 10. You're going to complete the table to explore these patterns in the exponents when multiplying powers of 10. You may skip a single box in the table, but if you do, be prepared to explain why you skipped it. So at this point, pause your video, try it yourself, and then come join back to see what happens. Okay, so we are going to fill in this table together. You've probably noticed some patterns. So based on what we see in that first one, we could start by writing the expanded form with 10 times 10 times 10 times 10, 4 tens, times another 10 times 10 times 10, 3 tens, which is a total of 7 tens that are getting multiplied. So with a single power of 10, we would say 10 to the 7th. Likewise for the next one, it'll look something like this. And we would write that with a single power of 10 as 10 to the 8th. In the expanded form of the next one, we work backwards. So we see that the first one is 10 to the 3rd because of the 3 tens being multiplied. The next one is 10 to the 5th. That's a total of 8 tens being multiplied together. So we would say 10 to the 8th. You get to this last one, and it allowed you to skip one of the boxes. This is going to be the one that we skip because I don't think you guys want to sit and write out 10 times 10 times 10, 18 times, and then another 23 times. Based on this pattern, we can see that it's going to be 10 to the 41st power. So let's talk about a rule for this. So as we move on to the second question, we notice that we were actually adding the exponents together. So for any variables that represent those exponents, in this case, 10 to the n and 10 to the m power, whatever those values are for n and m, we can say that we add them together. So here's why it works. If we have 10 squared times 10 to the 3rd, we have two factors that are 10. You see in blue 10 times 10. We have 3 factors that are 10 for 10 to the third, 10 times 10 times 10, which is a total of 5 factors that are 10. So we add those exponents together to represent it as a single exponent. In question 3, the state of Georgia has roughly 10 to the 7th human residents. Each human has roughly 10 to the 13th bacteria cells in his or her digestive tract. How many bacteria cells are there in the digestive tracts of all the humans in Georgia? Well, first you have to conceptually understand that you're multiplying these together. Now that we've developed a rule, we know that we're really just adding those exponents together, and that is equal to 10 to the 20th. How could you write the following 10 to the 15th times 10 to the 5th using a single exponent? Well, again, applying that rule, we can add 15 and 5 together, and that would be 10 to the power of 20. In general, what is a rule for multiplying 2 powers of 10 together into a single power of 10? The exponents of the 2 powers of 10 are added together, and that should meet your success criteria for today. You can read through the lesson summary if you choose to, but otherwise, you should be able to walk away from this video understanding how to explain and use a rule for multiplying powers of 10.